Imagine looking up at the night sky and realizing that something truly alien has just entered our cosmic neighborhood. Not a spaceship, not a signal, but a comet racing in from another star system. In July 2025, astronomers confirmed the arrival of 3I Atlas, the fastest and largest interstellar comet ever detected. Faster than ʻOumuamua, bigger than Borisov, and stranger than both. This frozen wanderer is moving at nearly 58 kilometers per second, so fast that the sun's gravity can't hold it. For the first time, 3 of the world's most powerful observatories, Hubble, JWST, and NASA's brand new SPHEREx mission, teamed up to capture its every detail. What they uncovered stunned scientists. An object with unusual chemistry, no tail, and behavior that defies the rules of comets as we know them. Could this be the missing link between the 2 interstellar visitors we've seen before, or something far more mysterious? In early July 2025, astronomers scanning the skies noticed something unusual. At first, it looked like a faint glowing speck, just another comet drifting through the void. But the orbital data didn't add up. Its eccentricity measured about 6.2, far beyond anything the sun could hold in orbit. That number told scientists everything. They were looking at a visitor from outside our solar system. Then came the speed, 58 kilometers per second, the fastest interstellar object ever observed. Faster than ʻOumuamua's mysterious dash, faster than Borisov's icy plunge. This wasn't just another comet. It was a runaway fragment from a distant star system. Early telescope images showed a diffuse glowing cloud, a coma surrounding something hidden at the center. Was this a massive comet 10 to 30 kilometers wide? Or just light reflecting off gas and dust? No one knew. Only the 3rd interstellar visitor ever seen, and this time caught early. Earth finally had a chance to study one in real time. On July 21st, 2025, the Hubble Space Telescope locked onto the strange visitor. What it found immediately changed everything. The nucleus, the solid heart of the comet, wasn't enormous. It was probably no larger than 5 kilometers across. The huge glow that made it look so big wasn't solid at all. It was the coma, a vast shell of dust and gas shining in sunlight. Even stranger, Hubble saw no tail. Most comets, heated by the sun, grow long shimmering trails. But 3I Atlas refused. It glowed like a floating orb, a head without a tail. Had we caught it too early, before it woke up? Or was this something fundamentally different? That mystery set the stage for the next act. With Hubble's clues in hand, astronomers turned to newer eyes, ones that could see the invisible. Between August 7th and 15th, NASA's SPHEREx mission scanned Atlas in infrared, cutting through the glare of the coma to reveal its composition. The results shocked scientists. Instead of the usual mix of water vapor and carbon monoxide, SPHEREx detected a massive halo of carbon dioxide gas. CO2 dominated everything, while water and carbon monoxide barely registered. For a comet, that's nearly unheard of. In our solar system, comets are mostly ice and rock. Water drives their bright tails. Carbon monoxide often joins in, forming jets and plumes. But a comet made mostly of CO2, that was something new. Perhaps Atlas was so ancient that its fragile ices had already evaporated, leaving only tougher CO2 trapped within. Or maybe it was born in a star system where comets followed entirely different chemistry. SPHEREx had rewritten the first chapter of Atlas's story. But to complete the puzzle, astronomers turned to a telescope built to see what no other could, the James Webb Space Telescope. On August 6, 2025, Webb's golden mirrors locked onto Atlas. If SPHEREx revealed the basics, Webb delivered the fine print. It confirmed the strong CO2 signature, but also spotted faint water ice, a whisper of water vapor, and traces of carbon monoxide. Atlas wasn't dead after all. Beneath its surface, pockets of water ice survived, protected from eons of cosmic radiation. The sun's heat just wasn't strong enough, yet, to fully awaken them. This made Atlas a hybrid, not fresh and volatile like Borisov, not dry and exhausted like ʻOumuamua. Instead, it straddled both worlds, an evolved comet halfway through its cosmic life. Scientists compared it to Comet Hartley 2, which bursts with CO2, while showing little water activity. For astronomers, this new chemical fingerprint hinted at something profound. Interstellar comets, just like stars and planets, age and evolve. Their chemistry carries the scars of their journeys across the galaxy. With 3 interstellar visitors now on record, astronomers could finally connect the dots. The first, ʻOumuamua, discovered in 2017, was small, elongated, and silent. No tail, no gas, no clues. Its strange acceleration even sparked talk of artificial origins. The second, 2I Borisov, found in 2019, looked like a textbook comet, volatile-rich and spectacular. The perfect example of a fresh traveler kicked out of a young star system. And now, 3I Atlas completes the lineup. Bigger, faster, and chemically unique. CO2 dominated, but still clinging to faint traces of water. Not pristine like Borisov, not empty like ʻOumuamua, but something in between. This trio tells a story. ʻOumuamua, the exhausted remnant stripped bare. Borisov, the fresh newborn, rich in ices. Atlas, the middle-aged traveler, weathered but alive. It's a timeline of cosmic evolution written in ice and dust. For the first time, scientists can see how comets from different star systems age and how their chemistry transforms across billions of years. Now, all eyes turn to what would happen next. As Atlas closed in on the sun, Atlas's story is still unfolding. Its perihelion, or closest approach to the sun, comes at the end of October 2025, roughly 1.36 astronomical units away, just inside Mars's orbit. Unfortunately, Earth will be on the far side of the sun, making direct observation difficult. But before and after that point, telescopes across the globe will watch closely. Will the hidden water ice finally sublimate, giving Atlas a faint tail for the first time? Or will carbon dioxide remain in control, confirming that it's an ancient, depleted relic? Some scientists are even exploring bold possibilities. Mars orbiters and other spacecraft could attempt quick snapshots or spectroscopic readings as Atlas passes by. It's a long shot, but even a single image would deepen our understanding of this alien traveler. Until then, observatories remain our eyes, tracking every shimmer, every flare, every chemical breath of a comet born around another star. Atlas may be unique, but it's also a sign of what's coming. For decades, astronomers thought catching an interstellar object was a once-in-a-century event. Then came ʻOumuamua, then Borisov, and now Atlas, each within just 8 years. The truth is, these travelers aren't rare. We just couldn't see them. That's about to change. The Vera C. Rubin Observatory will soon scan the entire night sky every few days with extraordinary sensitivity. Experts predict it will detect dozens of interstellar visitors each decade, turning these once mythic encounters into a new branch of science. Every visitor brings something different: composition, structure, history, and together they'll build a library of alien material, snapshots of how other planetary systems form and die. We won't need to cross light years to sample another world. The galaxy is already sending its messengers to us. In less than a decade, humanity has witnessed 3 interstellar visitors, each rewriting what we thought we knew. ʻOumuamua puzzled us with its silence, Borisov amazed us with its brightness, and 3I Atlas bridges the two, larger, faster, and chemically unique. Together, they reveal a story of cosmic evolution, from fresh beginnings to exhausted remnants. They show that even across light years, the physics of creation and decay are the same. And now, as new observatories rise, we stand at the dawn of a new era, one where the stars no longer feel distant because their fragments are finding us. So the question remains, if comets can cross between star systems, what else might one day arrive? Something not natural at all. If you liked this video, drop a like, subscribe, and share your theory in the comments, and I'll see you in the next video. Thank you for watching.